A key fundamental thing we need to use at advanced higher level is something called the Binomial Theorem in looking at expanding brackets of much higher power. And this is where this topic is going to come into play. What we're going to look at in this video is we're going to introduce the idea of the Binomial Theorem and what it is, and we're going to look at the formula for it when it's working with slightly more simple terminology and terms. Now, let's imagine we're going to do the following, and I want to expand these three sets of brackets here. Now, x plus y squared is quite straightforward. It's x squared plus xy plus another xy plus a y squared. So simplifying it gives me x squared plus 2xy plus y squared. Nice and easy. X plus y cubed, it's not too bad. It's just an extension of this because we're multiplying this answer by another bracket. So we've then got x plus y times the x squared plus 2xy plus y squared. So if I multiply that out, I then get x cubed plus 2x squared y plus xy squared. I then multiply everything through by the y, so I then get plus an x squared y plus a 2xy squared plus a y cubed. Again, simplify the whole thing, and I get x cubed. I've got 2x squared y here and another x squared y here, so I get plus 3x squared y, xy squared, 2xy squared, plus 3xy squared, then plus my y cubed. So again, that's not too bad. We had the x plus y squared here, so we could just use it there. X plus y to the 4, again we're lucky in that we've got the x plus y cubed here. So we know then that we're just multiplying it again by that. So x plus y times x cubed plus 3x squared y plus 3xy squared plus y cubed. We're going to have a few more terms in this one, but hopefully it's not too shabby. So I'll start by multiplying through by the x. So I get x to the power of 4 plus 3x cubed y plus 3x squared y squared, then plus xy cubed. Then multiply through by the y. I then get plus x cubed y plus 3x squared y squared plus 3x y cubed, then plus y to the 4. So what I can now do is simplify it and gather like terms and see what I get. So I start with an x to the power of 4. If you look, there's progressively lowering the powers of x, so I'm going to follow that route. So I'm going to then do plus, so I've got 3x cubed y, and then another x cubed y there. So I've got plus 4x cubed y. I've then got 3x squared y here, and another 3x squared y here. So I get plus 6x squared y squared. I've then got an xy cubed here, and I've got a 3xy cubed. So I then get plus 4xy cubed, and then I get a plus y to the power of 4. Now again, we were lucky in terms of that. How would you feel if I then said to you, great, let's expand x plus y to the power of 7? Well, this here, it took us a good few minutes to do that. Imagine we had x plus y to the 4 and we didn't know these terms. We'd have had to do even more work. Well, now if I've got x plus y to the 7, I've then got even more work to do, and I'll end up with a heck of a lot more terms. It's going to be very arduous for me to do. We need to figure out a way to do this better. One thing to look at is the coefficients. The coefficients of all the numbers of the x squared, I've got 1, 2, and then 1. If I look at the coefficients here of x cubed, I've got 1, 3, 3, and 1. And then if I look at the coefficients of x to the 4, I've got 1, 4, 6, 4, 1. That there is Pascal's triangle. So the coefficients of the brackets are actually built up in stages like Pascal's triangle. And similarly to that, each row of Pascal's triangle can be calculated using the function NCR. So for example, if I did 2c0, I get 2, 0, which I know is then 2 factorial over 0 factorial, bracket 2 minus 0 factorial. So that would then be equal to 2 factorial over 2 factorial, which is 1 times 0 factorial on the bottom. So I know I'm then going to equal 1. If I then do 2, 1, what I'm then going to get is 2 factorial over 1 factorial, bracket 2 minus 1 factorial. So I've got 2 factorial, so I've got 2 on the top. I've then got 1 times 1 on the bottom, so I get 2. If I then do 2, 2, what I end up getting then is 2 factorial over 2 factorial, bracket 2 minus 2 factorial. So 2 factorial and 2 factorial cancel, so I'm left with a 1. I've then got 2 minus 2 factorial, so 0 factorial, which I know is 1. So that equals 1. So that there is the second row of Pascal's triangle. If I was to then do it, I would then get the third row if I then did my 3c to the r. And if I did the whole lot of that, I would end up getting the next row of Pascal's triangle. If I did 4cr, I'd get the fourth row of Pascal's triangle. We can use this to our advantage because what we can do is use this to create what's called the binomial expansion of brackets. So what I can do is use this to help me generate the coefficients of any bracket x plus y to a power of n when I expand it in order to be able to make it a heck of a lot easier for me to do. So what I can say is x plus y to the n is equal to n0 times x to the n plus n1 times x to the n minus 1y plus n2 x to the n minus 2y squared all the way up to when I'm just left with a y to the r. Now think about it. I told you I was going in decreasing powers of x. Well, each time here, I'm decreasing in powers of x. If you go back and look, every time I decreased by 1 power of x, my y power increased. This is written in this general expansion here. So x plus y to the n equals the sum from r equals 0 to n of nr, x to the n minus r, y to the r. Let me show you how this works. I'm going to show you a couple of examples of expanding a pair of brackets using binomial expansion. So let's imagine I've got x plus 2 to the power of 5. Now if I was to try and expand that without this, that would be a heck of a lot of work because I'd have to square it and then I'd have to cube it, then the power of 4, then the power of 5. So that's a lot of work. But if I use binomial expansion and follow my x plus y to the n expansion, I can compare it with this bracket and say, right, so my x is still x, my y is 2 because it's plus 2, and my n is 5. So if I then look in the generic term and the way I wrote it before, I can say that x plus 2 to the power of 5 is equal to 5, 0, x to the power of 5, plus 5, 1, so I increase the bottom part of the expansion, x is to the power of n minus 1, so 5 minus 1, which in this case is 4. I then raise the power of 2, so it's then going to be times it by 2. I then do my next term, which is 5, 2. Again, my x power is going to decrease. It's then going to be times x cubed. That's then going to be times 2, and its power is going to increase to 2 squared. And I can then continue on like that until I hit the last term. So I get 5, 3, x squared times 2 cubed. I then get plus 5, 4, x times 2 to the power of 4. And I then get plus 5, 5 times 2 to the power of 5. So all I need to now do is calculate each of these coefficients here, and then I'm laughing. Once I've done that, it's just combining all the numbers and letters, and I've got my expansion. Well, 5, 0, that's equal to 1. So my first term is going to be equal to x to the power of 5. So the 5, 1, so that's 5 factorial over 1 factorial times 5 minus 1 factorial. So 5 minus 1 is 4. So it's essentially 5 factorial over 4 factorial, which is 5. But I've then got to remember, I've got plus 2, times 2. So I've got 5 times x to the 4 times 2. So I end up getting plus 10 x to the 4. The next term is 5, 2. So that's 5 factorial over 2 factorial times 5 minus 2 factorial. So that's 5 factorial over 2 factorial times 3 factorial. So I can cancel bits out there, and I get 5 times 4 over 2. 5 fours are 20, divided by 2 is 10. So I've got 10 times x cubed times 2 squared, so 2 squared is 4. So I then end up with 40 x to the power of 3. I've then got plus 5, 3 for this one. So that's 5 factorial over 3 factorial, bracket 5 minus 3 factorial. Well, that is the exact same as doing 5, 2. So 5, 2 ended up giving me 10. So 5, 3 is going to give me 10 again. So I've got 10 times x squared times 2 cubed, which is 8. So I've then got plus 80x squared. Remember previously we said NCR was equal to NC n minus r. Well, that's the way it works. So NC for this one is 5, 2. NC n minus r is 5C 5 minus 3, which is the equivalent of 5, 2. So the 5, 4 is the equivalent of what the 5, 1 was. So in this case, the 5, 1 was 5 factorial over 4 factorial, which was 5. So I've then got 5 times x times 2 to the power of 4. 2 to the power of 4 is 16. So I've got 5 16s, so I've then got plus 80x. Then my 5, 5, well that's 1. Any term where they're the same, or we've got something 0, is always 1, times 2 to the power of 5, which is 32, plus 32. Would you look at that? I've expanded x plus 2 to the power of 5 in one line of work. It's a hell of a lot easier than if I did x plus 2 to the power of 5 all on its own term by term. So that was x plus 2. See, when we have a negative, that's when we have to do a little trick. So let's imagine I've got x plus minus 2 to the power of 4. Now if we think of the generic term, it's x plus y to the n. It has to be a plus in the middle. So this bracket here, we have to rewrite as x plus negative 2 to the power of 4, which would mean my y is the equivalent of this second term, which is negative 2. So we have to bear that in mind when it comes to the expansion. It always has to be something plus something, and we have to take the negatives into account when we do that. So what I can then do is expand it the same way. So I know then that x minus 2 to the power of 4 equals, so I've got 4, 0 here, times x to the 4, plus my 4, 1 expansion, times x cubed times, well remember, it's negative 2 to the power of 1, so just negative 2. I've then got plus 4, 2, x squared, times negative 2 squared. The next term is then given by plus 4, 3, x times negative 2 cubed, then plus 4, 4 times negative 2 to the power of 4. So then calculating each of these coefficients, multiplying it all through, and then we've got our expansion. So 4, 0 is just 1, so I get x to the power of 4 as my first term. 4, 1 is just 4, so I've got 4 times negative 2, which is negative 8, so I then get take away 8x cubed. I've then got plus 4, 2, well 4, 2 gives me 6. I've then got negative 2 squared, well negative 2 squared is 4, so I've then got 4 6's, which is 24, so plus 24x squared. Then got 4, 3, well I'm working back down Pascal's triangle, so 4, 3 is 4, times negative 2 cubed. Negative 2 cubed is negative 8. 4 times negative 8 is negative 32. So I've then got negative 32x. And then my last term is 4, 4, which is 1, times negative 2 to the power of 4, which is then just plus 16. So there you go. Again, we've expanded x minus 2 to the power of 4 in a single line, rather than having to go through multiple expansions and expanding it over and over and over again and just giving ourselves more work to do. The binomial expansion is one of the most useful things that we can do when multiplying out these higher power brackets. So we need to bear that in mind and work with it effectively and efficiently, and remember that formula that we were given.